Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Fadil Shehzad and I am a student of BS Biotechnology. Today the topic of our presentation is dicalcium phosphate under the supervision of Dr. Hammad Majeed. Here is the list of our content which we are going to discuss in today's presentation topic. First of all, dicalcium phosphate, uses of dicalcium phosphate, history, formation of dicalcium phosphate, structure, physical and chemical properties, application in various industries, environmental impact, comparison with other phosphate group, recent research and development. What is dicalcium phosphate? Dicalcium phosphate is a mineral that belongs to the calcium phosphate family. It is a combination of calcium and phosphorus which are essential for various bodily functions. The substance is used as a food and feed additive due to its unique properties such as volumizing and anti-clumping effects and its ability to regulate acidity and improve texture in various food products. Dicalcium phosphate is a calcium phosphate salt with the chemical formula CaHPO4. It is a common additive used in various industries, primarily in agriculture, food, personal care, and pharmaceuticals. Key points and uses of dicalcium phosphate. Provide animal with necessary and calcium and phosphorus in their diets, added to certain cereals, pet foods, and dietary supplements. Used in a personal care products like toothpaste, cosmetics, and skincare for its opacity, bulking, and pH affecting properties. Employed as a tableting agent in pharmaceutical industries, utilized as a dietary supplement in dog treats, breakfast cereals, and noodle products. Serve as a source of phosphorus in animal feed production, improving performance in growth, fertility, and feed conversion. Dicalcium phosphate has three crystalline forms: monazite, anhydrous burshite, dihydrate, and hemihydrate. The dehydrate form CaHPO4 2H2O is the common and can be thermally converted into anhydrous form. Dicalcium phosphate is produced by participating a phosphoric liquid obtained from demineralizing decreased bone with hydrochloric acid, used as a saturated lime solution. The wet participate is then filtered, dried, and packaged for various applications. Next, we have history. To the 19th century, when brushite dicalcium phosphate, dihydrate, and monazite dicalcium phosphate were first described. However, the form intermediate chemical formula CaHPO4 to H2O dicalcium phosphate monohydrate remained elusive until its synthesis and crystal structure determination were reported in 2020. Historically, dicalcium phosphate has been used as a dietary supplement, tableting agent in some pharmaceuticals preparations, and in poultry feed. It is also found in some toothpaste as a tartar control agent. Heating dicalcium phosphate give dicalcium phosphate a useful polishing agent. The dehydrated form of dicalcium phosphate is found in some kidney stones and dental calculi. Understanding the crystal structure of different calcium phosphate like dicalcium phosphate is important for a range of subjects from geology. Next, formation of dicalcium phosphate. Dicalcium phosphate can be formed through several methods: by neutralizing calcium hydroxide with phosphoric acid which participate the dehydrated form CaHPO4 to H2O as a solid. At 60 Celsius the anhydrous form is participated. In a continuous process, CaCl2 can be treated with 2H2PO4 to form dehydrate. The dehydrate slurry is then heated 65 to 70 Celsius to form anhydrous CaHPO4 as flat dimonodite crystals. Dicalcium phosphate dehydrate is also formed in brushite calcium phosphate cement used for medical applications. Heating dicalcium phosphate gives dicalcium diphosphate a useful polishing agent. The dehydrated form is found in some kidney stones and dental calculi. Three forms are non-dehydrate, monohydrate, and anhydrous. Below pH 4.8, the dehydrate and anhydrous form are the most stable. Next, structure. The structure of dicalcium phosphate is a calcium phosphate with the formula CaHPO4 and its dehydrate. The dehydrate form is also known as precite. The structure of dicalcium phosphate dehydrate CaHPO4 to H2O has been determined by X-ray crystallography. It consists of sheets in the AC plane containing parallel chain of PO4 tetrahedra and calcium ion. The sheets are separated by water molecules which link the sheets in the B direction. In the anhydrous form, the structure is similar but without the water molecule. The calcium ion has a coordination of 8 with 6 oxygen from PO4 tetrahedra and 2 water molecules. The structure of dicalcium phosphate is important in various applications including fertilizer production and food additive medical uses such as toothpaste and dental cements. Physical properties. Anhydrous form triclinic crystals density 2.92 gram per centimeter cube. Dehydrate form monoclinic crystal density 2.31 gram per centimeter cube. Hardness particularly soluble in water and alcohol, soluble in dilute mineral acid like hydrochloric, nitric and acetic acid. Stable in air. Chemical properties. Molecular formula CaHPO4 anhydrous or CaHPO4 to H2O dehydrate. Molecular weight 136.06 gram per mole. Anhydrous solubility product constant 2.7 multiplied 10 to raise minus 7. Decomposes on heating, losing water of crystallization above 75 Celsius. Used as a source of calcium and phosphorus. Application in various industries. Dicalcium phosphate find diverse application across industries. First, food industry. Used as a buffering agent, dough modifier, emulsifier, leaving agent, and natural supplement in food and beverage. Animal feed, essential for providing phosphorus and calcium to animals, improving growth and fertility. Pharmaceuticals, commonly used in extended release tablets and some pharmaceutical preparations. Personal care, found in toothpaste, deodorants, and various cosmetic products for its properties like opacity and pH regulation. Industrial chemical utilized in toothpaste, pills, vitamins, and cosmetic skin products. Environmental impact. Dicalcium phosphate production has several environmental impacts that need to be addressed. The process with the greatest environmental impact are beneficiation, sulfuric acid synthesis, and phosphoric acid synthesis. Pollution from electricity and sulfur consumption should be controlled. Key substances that can bring serious environmental burdens include sulfur, electricity, beneficiation reagents, tailings, and phosphogypsum. Decreasing electricity and sulfur consumption should be priority for cleaner production. Waste from dicalcium phosphate such as phosphogypsum contain elevated amount of critical elements like rare earth elements. Separating uranium and radium from the residue will allow for reducing environmental impact of landfills and facilitate re-extraction. Incorporating dicalcium phosphate, eggshell powder, and pistachio shell culture into lead contaminated soil can be efficiently immobilize lead and reduce its bioavailability to plants. This helps mitigate the illogical risk of producing low quality food in contaminated soils. In summary, the main environmental impact of dicalcium production stem from electricity and sulfur consumption, waste disposal, and heavy metal contamination. Optimizing process, reducing key pollutants, and utilizing waste can help the minimize environmental footprint of dicalcium phosphate manufacturing. Comparison with other phosphate compounds. Dicalcium phosphate has several key differences compared to the other common phosphate compound. Monocalcium phosphate has a higher phosphorus content by weight and is more digestible polystock compared to dicalcium phosphate. Monocalcium phosphate derived from dicalcium phosphate via the HCl process had particularly high digestibility due to its purity. Tricalcium phosphate offers the lowest feeding value among inorganic phosphate compared to monocalcium phosphate and dicalcium phosphate. Orthophosphate like those found in dicalcium phosphate, tricalcium phosphate and monocalcium phosphate are immediately available to plants but can become fixed in soil within 2 weeks. Dicalcium phosphate is not prone to fixation and become available when plant roots exude acid to break it down. Polyphosphates take time to break down into plant available orthophosphates, allowing them to penetrate the soil and supply phosphorus over a long period. Heating dicalcium phosphate produces dicalcium phosphate, a useful polishing agent. The dehydrated form of dicalcium phosphate bricide is found in some kidney stones and dental. Recent research and development of dicalcium phosphate has been focused on various aspects. New production process. Perion Technologies has developed a patented process using sulfuric acid to produce dicalcium phosphate from low-grade phosphate sources, addressing the challenge of decreasing quality in phosphatic raw material. Biomedical application. Recent research has explored the formation and potential application of dicalcium phosphate monohydrate in functional biomedical material development, highlighting its higher metastability and phase transformation properties. Market growth and sustainability. The dicalcium phosphate industry is evolving to support sustainable food production, human nutrition, and environmental conservation with a focus on technological advancement, eco-friendly innovatives, and optimizing nutrient content. Aquaculture industry. Dicalcium phosphate play a crucial role in aquafeed formulation, supporting the healthy growth of farm fish and shellfish as the aquaculture industry expands rapidly. Waste utilization. There is a growth emphasis on utilizing dicalcium phosphate streams for variable elements like rare earth element and developing innovative process to minimize environmental impact. Thank you.